analysis in front of you. So once again, good morning to everybody and welcome to all of you. Okay. Okay, sir. Hello. Now, this is the concept of real analysis. Now, especially already you have completed the 50% offline classes there, and remaining 50%.
Sir, your voice is not getting.
Voice is not getting, sir. Hello? Sir, can
Sir,
you hear
you are
me?
audible, but your voice is not clear, sir. What you speak?
Hello? Are you clear, madam?
हेलो,
Is this clear?
वॉइस की क्लियरिटी नहीं है सर। आप क्या बोल रहे हैं वो समझ नहीं आ रहा है।
Okay, okay, okay. Please. If it is okay, madam. Hello?
ये ऑडिबल है सर, बट
Actually, please understand here. Actually, my throat problem is at the same time throat problem is there, and any disturbance, small disturbance is there. Please adjust me. Okay? Is it okay? Audio share is there? Hello?
ये सर एक बार वो स्पीकर आप हेडफोन निकाल के बात बोलिए, देखते हैं सर समझ में आता है कि नहीं।
Yes. Is this okay? Hello?
यस सर, यस सर।
Okay, okay, it's okay. Now, this is the third semester mathematics real analysis. Once again, I repeat the concept of real analysis in the UG third year syllabus part is. Now there are here 4 blocks. First block is real numbers and sequences. Now, please just you have to observe the screen share. Okay. Are you vision is there? Okay. Now, this is the first block, real numbers and sequences. And in the concept of the first block is unit 1 real number system and completeness. And the second one is the open and closed sets in the system of real numbers. And the third unit is the real sequences and convergence. And at the same time, second block is now in the entire the first block must be the surround the part of real number system and the sequences. That is the major part of first block. Second block is infinite series. Infinite series means when the series is infinite, some of the sequences must be arranged in the sequential order. Now that is the series is when it is finite series, otherwise it is an infinite series. This is the second block. Now, second blocks are also consisting, there are 3 units, and one unit is convergence of infinite series of positive terms, and the second one is test of convergence. And the remaining the unit is alternating series. Now there are 3 units in the second block. And again, third block is Riemann integration. This is very most effortful part of real analysis. Now, very important concept is in the especially in the real analysis is Riemann integration. Riemann integration. Okay. Now, especially this Riemann integration much more useful entire part of real analysis. Now, it is also consisting there are 3 units. One is the Riemann integrability conditions, and another unit is fundamental theorem of integral calculus, and last unit is mean value theorems of integral calculus. This is the third block. Especially we must concentrate especially in the third block. We are getting the one essay and 2 short answers, especially. Okay, and every block is also one essay is there and 2 short answers is also there. Okay, but here very much more interested the concept of Riemann integration, especially that is the third block. And the fourth block is sequences and series of functions. Okay, now the unit is the 10th unit is pointwise and uniform convergence, and next one is infinite series of functions. And the last unit is power series. Now this is the overall the syllabus. Especially fourth block, entire the concept is according to the definition, we must approach the some other problems and then you have to practice. Now easily to get the good marks, especially in the fourth block is there. Okay. Now already 50% offline classes over in your offline presence is there. But remaining 50% online classes where only 6 classes is there. Now these 6 classes I must explain the only important concept and to deliberate the in front of especially for the use of students, using of students, especially these 2 blocks. Third block and fourth block, then you have to practice and some other theorems and also practice the problems. Okay. Students, now just you have to see and refer the model paper is also there at the same time. Now that is the section A, that is the short answer questions. These 4 blocks is consisting these 4 blocks getting the 20 marks. That is the only just you have to answer the 4 questions and out of 8. Each block is 2 consisting of the problems. Each block is getting the 2 questions and from first block 2 questions, second block 2 questions, and the serial number is serial number 1 to 8. Now these are all 8 questions from the section A. Now these are all short answers. Now you have used it to achieve only just you have to answer only 4 questions is there. Now each question carries 5 marks, 4 into 5, that is the 20 marks is there. Okay, next section B is there, that is the long answer questions. Now each block we are getting the A or B. There are 2 questions from each block is there. Now either 9th question or 12th question from the block 1. Now each long answer question carries 10 marks is there. So from block 1 question is there. From block 2, 11th and 12th, that is the long answer question. Just you have to answer only one is there. Okay. Now remaining 9th and the 10th, 11th, 12th, 13th, 14th, that is the third block is there. That is also one of the long answer question. Okay. And the last but not least here, 15th and 16th is also from fourth block is there. Now that is also one of the long answer question. So 4 long answer questions. Now every question must carry one of the choice is there. Okay. Now each question carries 40 marks, 10 marks, and overall the 40 marks is there. So 40 plus 20, 60 marks is there from the especially short answer questions and the long answer question. Now section C is there. Now objective type. So already same pattern already you have to attempt the first sem and second sem is there. Okay, but here especially according to the third sem syllabus, you have to how to approach the easily to get the answer. Okay, objective type is 20 marks, multiple choice 10 marks, and match the following 5 marks, and the remaining filling the blanks 5 marks is there. Especially these 20 marks from the theory 15% is given from the objective type, and the remaining 5% from practical point of view. Okay. So now this is the pattern 18 marks is there. So this is the model paper of third sem of the part. Okay. Students, please listen carefully. Students, anyone respond here? Anyone please respond here. Hello?
Yes, sir.
Offline classes, first block and second block, is it complete or not? Hello?
Yes, sir.
Are you attend the offline classes or not? Hello?
क्लियरिटी नहीं है सर, आप क्या पूछ रहे हैं?
Actually, offline classes, are you attend or not?
Not attended, sir.
Not attended. So that's why that is the major problem, because without attendance of offline classes, now from the starting point of view also I will explain here, because very short time, only there are 6 classes here. These 6 classes I must explain only important theorems and problems. for the sake of examination point of view. Okay.
Right, sir.
Okay. Now just how this is the first class. This is the main basic fundamentals of real analysis. What is the RNS? This is the first block. RNS means, that is the short form, real number system. Okay. RNS means this is the real number system. What is the real numbers? Some of the real numbers must be arranged in the systematical order. Okay. Some disturbance is there, please. Mute is there. Hello? Okay. Hello, Avinashi, some problem is there. Hello? Please mute is there. Some disturbance is here. Hello? Sir Avinash ji, please mute. Okay. Now, this is the concept of real number system. Real number system means some of the real numbers must be analyzed in the systematical order. Now, though that order means some of the real numbers must be defined into the sets, that is called the set of the real numbers, must be defined into the sequences, that is called a real sequences. Real sequences is nothing but sequences. Okay. Now that is the main concept. When the real number must be defined into the sets as the systematic part. Now, in the same time, we must define the what is the bounded, what is the bounded, what is the lower bound, what is the upper bound. Now, these are all definitions must be involved in the real number system. Okay, that is called RNS. That is the first block. Now, without these definitions, we are nothing to move further concept. Okay. Now, when the real numbers must be defined into the sets, that is called the set of real numbers. That when at the same time, that is the script R. Double of the R means it read as the system of real numbers. Okay. Now, in the same order, what is the complete ordered field? This is one of the important definition. Complete ordered field means hello? Complete ordered field. That is the short form COF. Now, when the real number system, set of real numbers must be defined into the field of the part. That is called field axiom. Second one, order axiom. And the third one, completeness axiom. When these axioms are satisfied, that is called complete ordered field. Now, it's very simple concept. Suppose in the first block, one of the important concept is some basic principles of real numbers. According to the real numbers, just you have to explain the subset, indexed set, index of the set of real numbers, set of real numbers, and according to the some axioms of real numbers are there. Okay. What is the field axiom? Field axiom means, and before that, what is the group theory? Okay, set of the real numbers must be defined. Just you have to see and referring is there. Set of the elements is denoted by capital S. This is the collection of data. Okay. This is the collection of data is denoted by set. Given the set, when it is a finite, that is finite set. Otherwise, it is an infinite set. Now, those binary elements represented as A to Z. When it is denoted by A, B, C, and up to X, Y, Z. These elements are called represented as the real numbers. Okay. Now, according to the real numbers, these real numbers in between, just you have to define all those elements when the binary elements must approach the binary operation. What are the binary operations? This is the basic algebra. Without algebraic conditions, we are nothing but analyzation concept, because both are interlinked parts. Because especially here, algebraic conditions is there. So set theory group theory. Okay. Now, set theory, group theory means what is the group? Now, that is also in the further session, just you have to introduce the algebra part. Suppose that is the when the fourth semester. Okay. Especially what is the field diagram? Any non-empty set, any non-empty set of a mapping is said to be a field. First one, it has a unity. This is the pyramidal principle is there. So this is the middle finger. It represented as the unity of the elements. Just have to listen. See and hear. This is the my hand rule is there. Middle of the finger represented as the unity element. And this is the commutative. What is the algebraic properties? Closure exam, associative, and third one is the existence of identity, existence of inverse, and the fourth one is the commutative. When these properties are represented as the algebraic properties, some others referred as conditions and axioms, okay, laws, postulates, and some other represented as the as their convenience, they are represented as the laws. Okay, closure law, associative law, existence of identity, existence of inverse, and when these four conditions are satisfied, that is called a group or profile. Now, this is the structure of algebra. According to the structure of algebra, first of all, we have to define when the non-empty set of a mapping is said to be when the non-empty set of a mapping means now it is represented as the sum of the binary elements. Okay, a set which is empty, there is no elements. Otherwise, it is non-empty means it is consisting sum of the binary elements. Okay, now those elements are represented. These are all alphabetical elements. Okay. Now, what is the field diagram? Okay, field diagram is any non-empty set of a mapping is said to be a field. If it has a unity and it is commutative, and the third one, please listen carefully. It is a unity and it is commutative. Third one, any non-zero element must possess its multiplicative inverse. When these three conditions are satisfied, that is called a field. Okay. Next, that is the next second one is the order diagram. Order means already you have to practice in the lower session. Okay. Any two elements, just you have to take an A and B or any two elements. Now, in between any two elements, just you have to identify if it is A is less than B or A is greater than B or A less than or equal to B or A greater than or equal to B. Less than, greater than, less than or equal to, greater than or equal to. These are called orders. That is the order. Okay. And third one is the completeness exam. What is the completeness exam? This is also in the offline session, especially very much more useful concept. That is the first block especially. Because without exams, without boundary strategy, bounded definition, without bounded definition, we can't express and we can't move the further sessions. That's why just you have to introduce the field, what is the complete order field. Field exam, order exam, and third is the completeness exam. Okay. Any non-empty completeness definition is any non-empty set of real numbers which is bounded above. What is the bounded? Hello? Okay. Any non-empty set of real numbers which is bounded above, then it has supremum. Which is bounded below, it has infimum. Okay. Now, just you have to just see and refer this one. What is the lower bound, upper bound? Now, just you have to see and this structure, especially. Okay. The structure is there. Now, first of all, what is the completeness exam? Without definition, without this one, without bounded definition, now we can't explain the completeness exam. Okay. Now, just you have to take in the one of this is there. Capital B, any one of the set. and FB represented as the field. Students, listen carefully. See and observe here especially. Now this is the one of the real line. Hello? Now capital SP any non-empty set and FP any. Now that non-empty set represented as the one of the subset is there. Subset of the element is denoted by small s. And field of the elements represented as H and K. Now H is the lower value and K is the upper value. Now these two elements are represented as the field elements.
स्पीकर आप हेडफोन निकाल के बाद बोलिए देखते
Bound
हैं
definition. Hello, place. Now difference is there.
यस सर
Hello?
यस सर
Okay. Please mute is there. Please cooperate. Okay. What is the bound? Bound means to express the relation. Hello. Okay. Now, bound definition is to express the relation between the subset of the elements, to express the order relation between the subset of the elements and the field of the elements. That is called a bound. Please note down. Definition of a bound. Please note down. To express the students. Please note down. To express the order relation between the subset of the element and the field of the elements. And the field of the elements. That is called a bound. Suppose here the subset of the element is denoted by small s and field of the elements are denoted by H and K. So subset of the element is small s and here we are taking the element is H is there. Now in order in the real line H less than or equal to s and s small s less than or equal to K. Suppose we are taking the lower value is small h and the subset of the element is small s. Okay, h less than or equal to s means the same term represented as s is greater than or equal to h. Okay, when the subset of the element and field of the element is h. Now we express the relation is order relation is greater than or equal to. Okay, then the lower value to represented as when the lower value, field of the lower value, when the order relation is reverse of the part, h less than or equal to s, or s like greater than or equal to h. When the subset of the element greater than or equal to field of the element. Now here h is called lower bound. Okay, h is called lower bound. This is called the lower bound definition. And at the same time, s less than or equal to k. This is the subset of the element is small s and k is the upper value is there. Now, when the subset of the element is less than or equal to order relation is less than or equal to and field of the element is k is there. Here k is an upper bound of s is there. Okay. Now, according to the lower bound representation, next we have to define the when the lower bound of the greatest element is this is. Upper bound of the least element is this is. Okay, this is the lower value. When the lower value of the greatest element is this is. This is the upper bound value of the least element is this is. So that's why this is called lower bound of the greatest element is called greatest of the letter is small g, that is the representation. So here xb any one of the element, that element is greater than small g, not equal. Lower bound representation is greater than or equal to. In the same time, x is greater than g. Here g is the greatest element and here x is not consisting of given the field and the subset of the path. But g is the lower bound of x. That's why this is the small g is the lower bound, but not x. So this is called greatest lower bound. This is called infimum. Greatest lower bound is called infimum. And at the same time, upper bound of the least element represented is small l, but x is not in the field of the element and x is not in s. Therefore, L is the lower bound of the value. That's why X is less than L. So L is an upper bound of X, but not in X. So this is called least upper bound. According to the upper bound definition, small f less than or equal to K. Okay. Now, small k is the upper bound of the value. Now, this upper bound of the least element is represented as this is. Suppose we are taking is there. Now, one is the least representation of the value is 0.0001. Okay. Now, one is the least representation of the value 0.999. Okay. So this is called the here when the upper bound of the least element represented is L. Now, with respect to the X element, X is not consisting of field and subset of the part. So that's why X less than L. Here L is an upper bound of S is there. Now, here the greatest lower bound is called infimum and least upper bound is called supremum is there. Okay. Now, this is the main concept of lower bound and upper bound. Students, this is the boundary concept. Without the boundary concept, then we have I can't explain the further concept. That is the problematic part especially. And according to the one of the set is given is there. Suppose 1 plus minus 1 whole power n by n, and that is one of the set is there. Find the infimum and supremum of the values. Okay. So here is small n being a natural number. That natural number represented is n is greater than or equal to 1 is there. Okay. Now that representation, according to the representation, just to have see and refer. This is very most important concept, Riemann integration. Students, without following my instructions, you can't understand anyone is there. Only problems are not there. Okay. Analyzation concept must be the surrounded the part of theoretical part. Without this theoretical concept, we can't understand anyone is there. Okay. Especially, this is the third block, Riemann integrals. Very important concept. See and observe, listen carefully. If you have any doubt, please interact with me as a personal number. Okay. And at the end of the session, I will give my personal number is there, and to share the entire notes through WhatsApp is there. Okay. Now, this is the Riemann integrals. What is the Riemann integration? Okay. Now, according to the bounded definition, here small xb any one of the element is there. That element represented as it is consisting of the interval of this part. What is the interval? Okay. This is the when the both sides it read as F maps interval AB to R. It read as, listen carefully. This is the closed interval of the part. Now, that interval is consisting, one of the element is there. Here X is consisting, closed means both sides are closed. That the square bracket is closed both sides. When the square bracket both sides is closed, that is called closed interval. Okay. Let F maps closed interval AB to R be a bounded function, and now this is the meaning of this is the interval points. These points in between to represented as the X elements. Okay. Now this is the closed interval strategy. Closed interval AB means when both sides are closed. Now it read as F map closed interval AB to R be a bounded function. Now this interval AB, A is the initial value and B is the terminal value. In between, now those elements are represented as in the element with respect to the X nature. Now A is the initial element represented as the X naught, and B is the now that represented as the element is final element is represented as Xn. Okay. Now in between X0, X1, X2, and now these are there. Now to arrange the order relation with respect to the X elements. X0 less than X1 less than X2 less than and so on, XR minus 1 less than XR, and so on, XN. Initial point is denoted by A is nothing but X0, and the terminal point, that is the final point, is Xn equal to B. Just you have to see and observe this is the one of the real line. What is the integration? When the integration must be explained, defined by Riemann concept. This is the third block. Students, listen carefully. Without introduction, you can't achieve anyone. Okay. When the integration must be defined by Riemann. That's why this is the third block of the part Riemann integrals. Okay. When the initial point coincides with the terminal point. When the initial point coincides with the terminal point, that is called an integration. Okay, here A equal to, that is the initial point, is denoted by X0. Now, so in sometimes already in the intermediate section is there. Integral A to B. Okay, that is the represented as this is. Integration, some are denoted by, so there are so many curves are there. So that's not correct here. When the initial point coincides the terminal point, this is the closed curve is there. Okay, now in between the A and B, all those elements are called, it is consisting of the elements of X. So that is the arrangement of the X values represented as the partition. That is the capital P. Okay, just now see and refer this one. And again, I will see in your text is there. That is the that is the third block. Any one of the partition. Partition elements represented in terms of X values. Okay, because that's why, hello, that's why here F defined from, it read as students, each and every student must be, it is too clear here. Now it read as F defined closed interval AB to capital R be the real line. Every interval points defined on the real line. So that's why this is one of the real line. The real line of the interval points A and B. Okay, in between the points are called X0, X1, X2, and so on Xn values. This is the R subinterval is denoted by every 2 points represented one of the subinterval. X0, X1 is the first subinterval. X1, X2 is the second subinterval. And again, R subinterval is denoted by IR, XR minus 1 and XR. And nth subinterval is XN minus 1 and XN. Now, in between the interval points, those points are called partition points. That partition set is denoted by capital P. Okay, this is the formation of an integral. Okay, now that integral is defined by Riemann according to the real line, and those interval according to the interval points in between the interval points of the elements are in between the interval points are called partition points. Okay, now that Riemann integral is defined proper integration or improper integration. Proper integral means that is the definite integral part. So you just have to see and observe here integral A to B f of x dx. Okay, now improper integrals means indefinite of this part. Integral A to B at the same time integral with respect to the A and B, C the midpoint is there. A to C, C to B. This is the indefinite of this part. Indefinite means indefinite. This is the definite integrals. Integral A to B f of x dx. Indefinite means integral 0 to infinite f of x dx. Okay. Now there are two types of integrals, definite integral and indefinite integral. Now according to the partition points from the finite set in between closed interval AB on the real line, we are to just have to arrange the sum of the subintervals. Okay. Just you have to observe those subintervals denoted by, just you have to, first subinterval is denoted by I1. I1 means closed interval x0 and x1. Every subinterval must have a one of the length. Length of the interval is denoted by L of I1. It is denoted by del1 or mod I1. Please, no problem. So length means x1 minus x0. First length of the subinterval is x1 minus x0, represented as del1 or length of I1 or mod I1. Now, in the problematic part, this is the when you have to understand the concept. Now, to find the upper Riemann sum and the lower Riemann sum. Okay, without this one, some students are maybe jumped is there. Okay, now particularly just you have to follow the each and every point is there. Okay, please stay on the line. Okay. Now, first subinterval is denoted by I1. Students, just you have to check and each and every one. Avinash and Galaxy A10 and okay. Just you have to respond here only. Okay. Kaula Mamuna, Ponam Sharma, Ravi, Samhita, Italy. Okay. Students, listen carefully. Please stay on the line. Take that. Okay. Now, every interval must be defined. Every interval point. Now, this is the closed interval AB is there. In between the interval AB, we are consisting of the elements are called partition points. That partition points must be arranged given to the set. That set is called a partition set. That is denoted by capital P. Now, those points must be arranged. Every 2 points, every 2 partition points must be arranged one of the subinterval I1, x0 and x1. Every subinterval must have a length of the subinterval. Yes, I means subinterval. This is the third block. Students, listen carefully. This is the third block. It is easy to understand here. Every subinterval must have a one of the length. That length is denoted by first length of the subinterval is denoted by L of I1 is denoted by del1. At the same time, mod I1. That value is x1 minus x0. Second subinterval is according to the partition points, we are taking the x1 and x2. These 2 partition points represented as second subinterval. Though that's a second subinterval of the length is L of I2. Length of interval, length of second subinterval or mod I2 or del2. That is the representation. That value is, that length is x2 minus x1. So, according to the observation, these subintervals, the rth subinterval is denoted by IR. This is called rth subinterval, IR. Closed interval XR minus 1 and XR. Okay. Now, length of the subinterval is denoted by L of IR. It is represented as del R. This is called rth subinterval of the length. Length means L of IR. Okay. Length of the rth subinterval length is denoted by del R. That is mod IR. That length is, now in the multiple choice question is there. Rth subinterval of the length is del R equal to dash. That value is XR minus 1. And the nth subinterval is nth subinterval is xn minus 1 and xn. Both brackets are closed. That is called closed interval. Now then the order condition is A less than or equal to x less than or equal to b. This is the interval of the flow. This is the closed interval concept is A less than or equal to x less than or equal to b. Here x is now what, that is the meaning of x belongs to closed interval AB. Means A less than or equal to X less than or equal to B is there. X being the element. That element is consisting in between A and B. That element can be divided into so many partition points. Okay. Now all the length of all the subintervals. Sum of all the length of the subintervals represented as L of phi. Simply that is denoted by del. Every subinterval must have one of the length is there. All the length of the subintervals, when they are adding del 1 plus del 2 plus so on, del r plus so on del n. First length of the subinterval is x1 minus x0. Second subinterval is x2 minus x1. And r subinterval length is del r, xr minus 1. Now all length of the subintervals must be adding. We are getting the values xn minus x0. Remaining values are also cancelled here. So xn means that is the final value. B, that value is equal to B. X0 is the initial value, then equal to A. So length of the interval is denoted by L of phi. So that is denoted by del. So the value is B minus A. Okay, that is the summation del R. This value is then equivalent to what is the interval of length of interval means mod closed interval AB equal to dash. Now this type of questions is given into the multiple choice in the final examination. Okay, now this value is B minus A. This is the length of interval. Overall, the length of interval of the length is denoted by L of I equal to del. So that value is then equivalent to B minus A. Simply that is the representation as entire the concept is summation del R equal to 1 to n. So this value is then equivalent to B minus A. So that is the length of I. That value equals to del. This is the main concept, students, very important. Okay, and at the same time, Riemann sums. Riemann, according to the Riemann integrals, Riemann integration is defined by Riemann. So he was defined on closed interval AB on real line. Okay, what is the Riemann sum? Riemann is one of the mathematicians. Students, listen carefully. This is the third block concept. Unit 3, block 3, this is. Okay. Third block of the concept is Riemann integration. Then now easy to practice here. Okay. Riemann sums. Riemann sum means Darboux sum. At the same time, it is also read as Darboux sum. Okay. And at the same time, this is also called partition of F. Okay. In examination is given, define Riemann sums and define Riemann integrals. Define Riemann sums and Riemann integrals. Riemann sums means that is also called a Darboux sum. That is also called partition of F. There are two types of Riemann sums. One is the lower Riemann sum and the second is the upper Riemann sum. Okay, students. Every subinterval must be represented as the lower value, upper value. This is the law. Now those values are depend on it is completely depends upon the function. Those subinterval values depends upon the function, and then to find the value of lower Riemann sum and upper Riemann sum. Okay, and according to the Riemann sums, they are defined Riemann sum means if F maps interval AB to R, first of all, you have to write this one. Let F from interval AB to R be a bounded function. If A equal to x0 less than x1 less than x2 less than so on, xr minus 1 less than xr less than xn equal to B. Okay, this is the finite partition set. It is denoted by this case. According to the partition set, then we have to define the Riemann sums, lower Riemann sum and upper Riemann sum. Lower Riemann sum is denoted by L of PF. Now, simply lower partition of F. When the function, according to the function, To define the partition set, function of the element, that element is consisting of the interval, according to that interval to define the partition set. So that's why this is called lower partition of F or lower Riemann sum or lower Darboux sum. There are three types of representations. Simply, that is the division, summation, small mr and del r. This is del r, del r. Okay, small summation, small mr and del r. Here r varies from 1 to n values. Okay, upper Riemann sum is denoted by u of pf. Now it read as upper partition of F, upper Darboux sum, upper Riemann sum on given the function is F and P be any one of the partition. So upper Riemann sum is denoted by U of Pf, that equals to summation capital Mr and del R. Okay, here small m represented as the infimum and capital M represented as the supremum. Okay, now that is the final interval of this part. Closed interval AB, here AB the lower bound and B the upper bound. And according to those interval points, to represent the partition points are there. Every subinterval, those partition points to represent the number of subintervals, I1, I2 and so on IR. And first subinterval of the lower value x0, upper value is x1. Those lower and upper values to represent into the function, we are getting the value is infimum and supremum of the value. That infimum value is m1 and supremum value is capital M1. Okay, now there are so many problems are also practiced in the further session. Okay, and upper lower Riemann sum is the L of Pf equal to summation small mr and del r, and U of Pf upper Riemann sum equals to summation capital Mr and del r. Here small mr and capital Mr is the infimum and supremum of the rth subinterval. Okay, and detailed we have to detailed part L of Pf equal to summation small mr and del r, that is here r varies from 1 to n. Put r equal to 1 is there, m1 del 1 plus small m2 del 2 plus so on small mn and del n. Okay, upper Riemann sum equals to U of Pf equal to summation capital Mr del r. In the examination session is also there. The final examination, simply you have to write the L of Pf and U of Pf. Okay, now this is the compulsory. According to the definition, then we have to approach the so many theorems are there. U of Pf equal to summation capital Mr and del r. That is here r varies from 1 to n values. Capital M1 del 1 plus, capital M2 del 2 plus, so on, capital Mn and del n. In those upper Riemann sum, what is the difference between the upper Riemann sum and the lower Riemann sum? That is called oscillatory sum. That is called oscillatory sum. It is denoted by W of Pf. Where oscillatory is the first letter O is there, O of Pf. P means partition and F is the function. So oscillatory sum is denoted by W of Pf or O of Pf. So simply represented as the U of oscillatory sum definition is U of Pf means upper Riemann sum minus lower Riemann sum. To just have to substitute those values, summation capital Mr del r minus summation small mr and del r. And summation here that is the common part. Summation del r is the common part. Summation of capital Mr minus small mr of del r. Here r varies from 1 to n. So that is the oscillatory sum definition. Okay. Now, especially in this session, what is the function defined on the real line of this part, closed interval AB, and in between the closed interval AB, what is the partition points? And according to the partition points, how to deviate the subintervals. According to the subintervals, then we have to represent the length of the subintervals. And according to the concept, we have to just to must define the lower Riemann sum and upper Riemann sum, and when the upper Riemann sum is lower Riemann sum, the difference between the upper Riemann sum and the lower Riemann sum, that is called oscillating sum. Some properties are there. Now, simply oscillating sum is summation capital M r minus small m r of del r. What are the properties of just one of the important property? Okay, if there is a partition set is denoted by pi of closed interval AB. The set of all, there are so many partitions of closed interval AB is there. Set of all partitions is denoted by pi of closed interval AB. Suppose we are taking any two partitions, P1 and P2. There are two partitions. P1 is P1 is finer than P2, or P1 is subset P2, whatever it is. It read as P2 is finer than P1, okay, and P2 is refinement of P1. Okay, what is the norm of the partition? The maximum length of the subintervals of the partition is denoted by norm of P. That is called double mod of P. It is denoted by delta of P. Maximum of del 1, del 2, so on, del r, so on, del n. Simply common refinement. This is called common refinement. The union of any two partitions is called common refinement. Okay, that is the variation. Any two partitions you are taking in the partition set. P1 is P1 is higher than P2 is there, and norm P2 less than or equal to norm P1 is there. Okay. Now always norm of the partition is always to process to 0. Okay. Now this is a very important concept. One of the important theorem is here, and some other problems are also practiced here. What is the, just you have to see and refer is there. Please see your textbook. Hello, please stand the line. Now, if f maps interval AB to R is a bounded function, and PB any one of the partition set, from the partition set, we are taking any one of the partition is there. Upper Riemann sum is greater than or equal to lower Riemann sum. This is the first property. Second one, the negative partition, and then on the negative function, upper Riemann sum on negative function equal to the negative of lower Riemann sum. Now these are all properties. These three properties is combined in one of the theorem is there. Very important. Now these three theorems, are also involved in your textbook is there. Just see and refer. First, upper Riemann sum is greater than or equal to lower Riemann sum. Upper Riemann sum on negative function equal to negative of lower Riemann sum. At the same time, lower Riemann on negative function equal to negative of upper Riemann sum. These three results must be involved into the one of the theorem is there. Okay. And see, and just you have to see and observe this one. If f of x equal to x, given the function equal to x, it is defined on closed interval 0, 1. Interval point is 0 and 1. Okay. And in between the 0 and 1 can be divided into three parts. Now, these points are called partition points. According to the interval, can be divided into that is the third subinterval of the part. 0 and 1 by 3 first subinterval, 1 by 3, 2 by 3 second subinterval, 2 by 3, 1 is the third subinterval. These three subintervals must be defined, and these three length of the subintervals are also there. According to the length of the subintervals, and when the infimum, first subinterval of the infimum is 0, second subinterval, first length of the subinterval is upper value is 1 by 3. This value is substituting this is f of 1 by 3 equal to 1 by 3. Suppose f of x equal to x square is there. So this value f of 1 by 3 equal to 1 by 3 whole square. That is the capital M1. Okay. Now those problems are also see and refer. Just see in your textbook, please. Just see. This is the third black in your textbook. Please stand the line. Students, listen carefully. This is your textbook. Unit 7. This is the third block, Riemann integrability. Okay. Already, just you have to 7.2.1. Already, interval is defined is there. Now that interval is closed interval AB. Now, this is the closed and bounded interval in the real line. Partition set is x0, x1, so on, xn is there. In between A and B is the interval for these are all partition points. Okay. Now these enter the concept is there here in your textbook. 7.2.2. This is the partition set. According to the partition set, we must arrange the subintervals are there. And according to the subintervals, then you have to arrange the length of the subintervals. Del 1, del 2, and del n. All the length of the subintervals of the maximum part is called norm of the partition. Norm of the partition is denoted by norm P or delta P. Okay. Now, especially in this session, I must explain what is the Riemann integrability concept. Entire this concept is there. Lower Riemann sum and upper Riemann sum. Okay. It reads as lower Riemann sum is denoted by L of Pf equal to summation MR del R or MK del K. Whatever it is. Here K varies from 1 to n values. Okay. Upper Riemann sum is upper U of Pf equal to summation capital MK del K. Okay. Now this is the when the upper Riemann sum and lower Riemann sum in between the difference is called oscillatory sum is there. Okay. Enter the concept must be delivered, especially in this session. If you have any doubt, please just have to explain here. Okay. Please note down my number. Enter the notes through the WhatsApp. I will send through WhatsApp. Please note down. My mobile number is 9989 476833. 9989 476833. This is my mobile number, and please share the UG third year. Anyone is created here, UG third year students. This is third term students are also there, or real analysis students are also there. No problem. One admin is there. All the students must be joined in this group, and to share the entire the concept is there. Okay. Okay. Now this is just you have to refer 7.2.6 theorem is there. Okay. This is. And next class I will explain how to define the lower Riemann sum and upper Riemann sum. This is the lower Riemann integral 7.2.9. Okay. This is the 7.2.9. Just you have to observe, define the Riemann sum and Riemann integrals. Okay. Lower Riemann integral is lower limit a to b f of x dx equal to lower Riemann sum of the supremum value is called lower Riemann integral. And the lower Riemann sum of the supremum value is called lower Riemann integral. It is denoted by lower limit a to b f of x dx equal to supremum of L of Pf, such that P being any one of the partition set. And upper Riemann sum of the infimum value is called upper Riemann integral. It is denoted by upper limit a to b, upper limit a to b f of x dx. This is called upper Riemann integral. Now these two definitions define Riemann sum and Riemann integrals. Now this is one of the important questions given in the final examination. Without the definition, we can't learn any one is there. Okay. Lower Riemann sum and upper Riemann sum. And according to those definitions, you have to define the lower Riemann integral, upper Riemann integral. Lower limit means a underscore. Lower limit a to b f of x dx. This is the lower Riemann sum of the supremum value. Upper Riemann sum of the infimum value is called upper Riemann integral. Okay. Now, these definitions must be practiced, and the remaining the concept must be delivered in the next class. Okay, students, if you have any doubt is there? Students, please respond here. Are you any doubt? Hello? Friends, hello? Here is Varun Sharma, Ravi,
Yes, sir.
are you clear?
मैं क्या बोलूं सर, मुझे तो, मैं सिर्फ आपका क्लास सुन रही हूँ, बट
Okay,
वॉइस
okay.
ही क्लियर नहीं थी।
Actually, this is the online, madam. Okay, there are so many struggles are there. Actually, much more effort, especially just you see, just observe this one.
Sir,
Okay,
please
ma'am.
clear your voice. Clear your voice.
Clear? Is this clear, sir? Okay.
Yes, sir. Yes, sir.
Okay. Much. Please note down my number. 9989 4768 33. Okay. 9989 4768 33. This is my mobile number. Okay. Just have to see and refer this one. Good morning to everybody. 9989476833. This is my mobile number. Please, please join. Use the third year students. One of the group must be arranged here. Enter the notes to deliver through the WhatsApp is there. Okay. Now this is the flow.
Sir, any WhatsApp group is there?
Yes, sir. You must be created there. First of all, it must be created. Okay. Hello, sir. Any student must be created. Third semester student must be created one of the there, and admin is also one of the admin is there, and any student is also must be created, and to deliver the subject and through the WhatsApp. Okay. Some important questions. Okay. Any doubt? Any doubts, sir? Do you have any doubt? Okay, we will meet again next class on 21st, maybe. Okay?
राइट सर।
Okay, sir. Thank you, one and all. If you have any doubt, please share and to share my mobile number and to explain the deep subject through WhatsApp is there. Okay? Thank you, one and all. Once again, wish you all the best.
Thank you, sir.
Most welcome.
थैंक यू सर।
Most welcome.
और भरने के बाद कॉम्पिटिशन आ गया 15 दिन में
आवाज बड़ी करो जी।
Sir, I have one doubt regarding the question paper. Can I ask?
Hello? Tell
Hello?
me, madam. Tell me, madam.
Yeah, about the section C, sir, we have a change in this academic paper, right? This year's paper. So, what questions would you think would be coming to us in the section C? And they actually carry the, almost the passing mark of our papers, sir.
Okay, already this is the first sem, second sem. Already have to, are you open or not?
Your voice isn't clear, sir. Could you mind repeating your question?
Okay, okay, so already just you have done the first year, okay?
Yes. Yes.
According to see in the same manner, and second it is also in the same manner, question paper is also there. There is no
Yes.
change.
Yes.
Okay. Come on, in the same manner, there is same, in the same point of view, same pattern, there is no change.
Yes, sir.
Okay. Okay, once again, all the best and wish you good luck, and we will meet in the next class. Okay,
Okay, thank you, sir.
most welcome.
Yeah.